Look, I was getting frustrated with parts of the animation workflow inside of Blender, so I built an add-on to make my life super easy. Here's what was driving me nuts and how I solved it. First off, I got tired of taking all these little steps just to edit my pose at the end of an IK range, or even smushing the FK and IK frames side by side and editing both frames. With my tool, I can just go to the last keyframe of an IK range, edit my pose, then go on working on the rest of the animation. Because with my tool, the final keyframe of an IK range remains in IK, and the tool automatically snaps the FK chain to the IK chain. Second, I have no confidence in this sort of pivoting system where I twist a foot to the side and yet the pivot remains at the base of the foot. This isn't how the body moves, so I designed a pivoting system that has a movable pivot point. That way I can do this sort of stuff. No problem. Finally, I'm just tired of all this extra noise in the viewport with all the extra bones from the different kinematic chains. My tool, quote, hides the inactive kinematic chain as I scrub across the IK ranges, so I don't have to figure out which chain is currently controlling a limb. I say hide in quotes because, as you probably know, hiding a bone in the viewport actually hides it in the animation timeline as well. And we can't be having that. So my tool uses a special little trick to make the inactive chains invisible without hiding the bones from the timeline, and I can toggle the visibility of those inactive chains if I so wish. Also with motion paths, I was tired of digging down to the deformation bone to set up a proper motion path, because you know, if you set up a motion path for a bone on a kinematic chain, well, it only works for that chain. My tool sets up the motion path for the actual bone that matters, the deformation bone, even when you're just selecting one of the animation bones. Just don't waste your time. If you want to take advantage of these speed boosts, you can rig your character with my tool on any 3 bones that are chained together. The rigging setup comes with all the quality of life features you'd want and expect, like batch renaming, repositioning, parenting, or even clean dismantling. And the FK chain of rigged limbs even come with a follow rotation system, which really comes in handy for walk cycles. The tool even comes with a way to assemble follow rotation on individual bones. And to tie it all up, the tool comes with 4 pre-rigged models, so you can jump right into playing around with the tool before even rigging it on your own character. Yeah, so let's get into how to use the tool. Installing is simple, just choose the PI or zip file and you're good to go. In pose mode, you can add all the major buttons to the speed shelf from this drop-down menu. I'll explain all these settings in the automatic features section, and this button works with the alignment feature. If you right-click in the viewport, you have access to most of the pose mode options via the tool menu. You can find the other handful of options by right-clicking the dope sheet, graph editor, or timeline. I'll talk about these towards the end of the IK ranges chapter. In edit mode, you'll find your rigging features in the right-click menu. Also, just a heads up, there's some useful information about bone collections in the rigging section, which I think all animators who use the tool should be aware of. Okay, let's talk about the meat and potatoes, creating and working with IK ranges. It's pretty simple. You can use these 3 operators to define IK ranges and work with FK. You can find these buttons in the right-click menu as well. Start IK as IK0, end IK as IK1. So I'll create the beginning of a range for this leg and the end of a range. While inside of this range, or even while on the 2 keyframes, the leg is in IK. For now, everything outside of the range is also in IK. I can access FK one of 2 ways. If I create another IK range, the leg is in FK between the 2 ranges. Or I can go outside the ranges and slap down an FK column wherever. Keyframes in the start and end columns need to stay together. All the animation channels for all the animation bones of both the IK and FK chains are keyframed here. These are the points of handoff between the IK and FK chains. See this line right here? It belongs to the kinematic mode property that lives on the middle IK bone. If the value of the property is 0 or 1, the limb is in IK. If it's between 0 and 1, the limb is in FK. The system works by changing the interpolation of this keyframe where needed. If ever you change all of the keyframes of your animation, just hit this button to update the interpolations. Auto interpolation is available as an automatic feature of the tool, and I talk about it in the automatic features chapter. When you go to the start or end of an IK range and adjust your pose, you can align the FK chain to the IK chain with this button. It's also referred to as snapping. This is also available as an automatic feature of the tool, and I talk more about this in the automatic features chapter. The great thing about this tool is it actually batch aligns the various starts and ends. So let's say I go to this keyframe column, make an edit to my pose, but forget to align the chains. Then go over here, change my pose, then use the button. It will batch update both of these frames. There's a limiter in the drop-down menu in case you have a giant animation with tons of IK ranges. This is how many keyframe columns are aligned per side of the current frame. Also, the way the tool works, alignment only happens at the start and end of IK ranges. No snapping needs to occur on the FK columns because no handoff happens there. This button selects all the animation bones for a limb that has at least one bone selected. This is great for isolating all the bones of a limb, even if the chain visibility is toggled on or off. We'll get to the demo in just a moment, but I just want to finish this section by giving a brief description of these operators. This selects the nearest keyframe column for any limb that has an animation channel selected. This deletes the kinematic mode property on a keyframe column and returns the colors to default. This removes any redundant FK columns that are between two IK columns. This updates the keyframe colors for columns. This is great if you've dragged some keyframes onto a column and you're losing sight of it. This is the pivoting assembly. It comes with every assembled limb. You have your end bone, which in this case I'll refer to as the foot bone. It's the child of the pivot bone, and the pivot bone is the child of the location bone. Use the location bone to, well, relocate the chain. Its rotation has no effect on the chain. Use the pivot bone to rotate the foot. Here's how to move it. Unlock it with this button. You can also find it in the right-click menu right here. This button also locks the foot and location bone in place while you move the pivot bone around. Move the pivot bone where you want it to be, then lock it in place with this button. This button also keyframes the pivot bone and the foot bone. If you unlock the pivot bone but change your mind and want to lock it without keyframing, you can use the unlock button once again. Avoid directly animating the foot bone. The animation channels aren't locked. That way you can still reset its position along with the other two bones. Here's how to create part of a walk cycle where the pivot bone changes position. Create the movement with the location bone. Then at the start of the animation, set the pivot bone to the heel and rotate up. Scrub halfway through the animation, make the foot flat, then set the pivot bone to the front of the foot. Move to the end of the animation and rotate the pivot bone. Notice here there's some lines. The location data for the foot and pivot bones need to stay constant, so we use constant interpolation. If ever they aren't, use the same button as before to update their interpolations. Also, don't rotate the bone while you're resetting the position of the pivot point. You want the rotation to continue moving smoothly between changes. Think of the keyframes of the foot and pivot bones as a married couple wherever a change occurs. You want to move these keyframes together to maintain a clean change. Here's a demo of doing something fancy. I use the follow rotation feature for the toes, which I discussed in the follow rotation chapter. Chain visibility is pretty straightforward. Just click this button to toggle the inactive chains. It works by altering the scale of the bone's custom shapes. When inactive, the scales of the custom shapes are set to 0, otherwise they are normal. This system won't work if you aren't using custom shapes, which you can change to whatever you like. The drivers make it practically impossible to directly change the scales of the custom shapes, so I added a set of tools to help you with that inside the Edit Custom Shape Drivers button. First, remove the drivers, make your adjustment, then drive the custom shapes. This button resets the custom shape scales to their original setting. The system works on a custom property you can find on the armature, and it runs off of the kinematic mode property that's keyframed with the IK columns. The follow rotation system is pretty simple. When off, the limb will not follow the rotation of its parent. When it's on, it will. This isn't as elegant as the IK ranges system, meaning you still need to squish the end of one state up to the start of another state. But it's pretty simple. It just keyframes the animation channels for the base FK bone along with the follow rotation custom property. You can add the two buttons to the speed shelf or find it here inside of the right click menu. The follow rotation keyframes are designed to remain in constant interpolation, so use this button to update their interpolations if changed. If you assemble the follow rotation system onto any individual bones, and I cover this in the rigging section, these buttons work on those assemblies as well. If you have a bone of an assembled limb selected and use the motion path feature, it will calculate the motion path for the underlying deformation bone that you built the chains on. This way you don't have to dig into your deformed bone collection and calculate the motion path on that bone. It's just a big time saver. The options that come up are essentially a copy and paste of what you'd find from Blender's default menu. You can then use this button anytime to update the motion path if Blender isn't doing it for you. The tool also comes with an auto motion path updater I talk about in the automatic features chapter. To remove the motion paths, just use Blender's default option, Clear Motion Paths. The automatic features can save you a ton of time. They require a certain set of conditions to be true, like all the keyframes of columns need to be present and up to date, and auto keying needs to be turned on. I wrote up a rather long article in the user manual that explains this whole list of filters that must be satisfied, but the long and the short of it is, they'll work when you're on a keyframe column and a bone from the limb is selected. I also added this little diagnostic tool that tells you when the automatic feature worked and when it hasn't, or if it's waiting for something. You can even click on it and it will try its best to explain what it thinks the problem is. The auto align chains feature is certainly the most useful of them all, and I use it almost all the time. If I'm doing a lot of keyframe interpolation changes, like going between blockout and splining quite a lot, I'll turn on the auto interpolate feature, otherwise I'll keep it off. And the auto update motion path feature is pretty cool in theory, but it really only works inside of the scenarios I outlined, which sometimes leads me to just using it for very specific situations. These three settings affect the automatic features. Auto alignments by default are kept low, but you can adjust this if you have a fast computer. Max limb selection count is set by default to 4, so if you have a rig that has all the toes and fingers assembled, the tool won't update every single limb and bog down the updates after every little action. Delay before firing is how long the tool waits after you take an action to fire. 0.25 works just fine, and I find the tool misses firing if you decrease it to 0.15 or lower. The Kinematic Tool comes with 4 pre-rigged models. The Uniped and Biped are a great way to start playing with the tool and try some super simple animations. I recommend every animator start with the Uniped at least for a short session. The prototypers have their arms and legs rigged with the Kinematic Tool, and the toes, neck, and head rigged with the individual follow rotation assemblies. You can use the prototypers in any commercial project except for merchandising and resale, so feel free to use it in a commercial game or in an animation you make for YouTube. Have fun. The tool can assemble a kinematic limb on any 3 bones that are chained together. I recommend those 3 bones being your deformation bones. There needs to be at least a tiny little bend between the base bone and the middle bone to help determine the direction of the joints. Once assembled, let's start by taking a look at the bone collections that arise. Any of the bone collections that are labeled as kinematic limb are the ones you want to baby. Their custom property value is named kinematic limb. Just avoid adding or deleting bones from this collection. If you do, it's all good though, you can just add them back. What's included in the collection are the base bones you use to assemble the limb along with the IK and FK bones. This bone collection is renamed with the label you give at the top of the renaming panel, which I'll cover in a moment. These 3 other bone collections that are created are just quality of life for you. You can move bones in or out of them into your own preferred collections, and when you're satisfied you can even delete them. I animate with the limb collections turned off and only the animation collection turned on. This helps prevent keying of mechanical bones and deformation bones. Every bone that's part of an assembly is tagged with a custom property you can see in edit mode. Avoid deleting those custom properties. The various operators of the tool use these tags to make choices, which also means avoid duplicating a bone from the limb and using it elsewhere without first deleting the custom property. Using the dismantle feature will remove these tags for you, assuming the bone collection is intact. It basically tries to strip it down to its original state. If a bone still has some of these custom properties and you try to reassemble a new limb, you won't be able to. Make sure they're all cleaned up before you try to reassemble a limb. If you change your model and need to update the position of the rig, you don't need to disassemble it and go through the process of assembling it again. You can move almost any of the bones of the limb and use the Update Limb Position feature, and it will reposition the rest of the limb to the active bone. It'll even recalculate the pull angle. You can batch rename an entire limb with this fancy panel. Play around with it and you can see what the results will be in the lower section. I use the suffix inverse and forward to describe my IK and FK bones, but you do you, fam. When you assemble a limb, the tool builds 4 really simple custom shapes. You can find them in the Kinematic Tool widgets collection. Feel free to move this collection wherever you'd like to. If at any time you accidentally remove a constraint or a driver, first try using the pose mode operator, reset constraints and drivers, before disassembling and reassembling a limb. The operator does its best to restore a limb to most of its factory settings. If that doesn't do the trick, dismantling and reassembling is pretty quick. You can set the parent of the assembled limb, such as an arm to a collarbone with set limb parents. You can make downstream bones the child of the assembled limb, like fingers to a hand, using the parent bones to limb option. Just for convenience, you might want to parent your knee pole to the foot bone to make animating easier. I don't, however, like to parent the pole of the elbow to the hand. It doesn't really feel right to me, but it's up to you. Add bone to limb and remove bone from limb affects the auto align feature. Say if you move the torso around and it affects the position of the legs while they're in IK, well, you'd want the auto alignment to fire, so you can register whatever bones you like to specific limbs. You can assemble a follow rotation system on a single bone, decide which axis of its parent bone it follows, choose its parent bone in the process and the root bone of the rig. The edit bones acquire their own custom properties similar to a limb when it gets assembled. You can then rename the 2 new bones with the renaming panel. This is a good place to add your left-right tags. And you can dismantle that system if so desired. Finally, I want to talk about symmetrizing and troubleshooting problems. Symmetrizing is the fastest way to set up rigs, but for some odd reason Blender doesn't symmetrize drivers. So I built a feature into the tool that's meant to try and solve that issue. Once you've left-right named all of your bones, selected all of them, and symmetrized, immediately after use the Reset Constraints and Drivers button, select all the bones, and use the Reset Drivers on Custom Shape Scales button. The new limbs will acquire their own bone collections, and if you switch over to pose mode and fiddle with the chain visibility command, that's a good way to tell if the trick worked. That should try and sort out new limbs that are assembled on either side of the x-axis. If limbs lie across the y-axis, they won't be recognized. If that doesn't work, you can always assemble new limbs on your symmetrized deformation bones. Check out the user manual for more information, and let's get animating.